Apache Kafka is a powerful distributed event streaming platform that has gained immense popularity for its ability to handle real time data feeds. Let's dive into its core components and understand how they work together to create a robust messaging system. First up, we have Amwon producers. These are the applications or services that publish messages to Kafka topics. Imagine a producer as a news reporter sending out updates. Producers can send data in various formats, such as JSON or Avro, and they can choose which topic to publish to. They also have the ability to specify message keys, which help in determining the partition where the message will be stored. This is crucial for maintaining order within a partition. Next, we have topics. A topic is essentially a category or feed name to which records are published. Think of it as a channel on a TV. Each topic can have multiple partitions, which allows Kafka to scale horizontally. Partitions are the building blocks of topics, and they enable Kafka to distribute data across multiple brokers, ensuring high availability and fault tolerance. Now, let's talk about brokers. A broker is a Kafka server that stores data and serves client requests. In a Kafka cluster, multiple brokers work together to handle the load. Each broker is responsible for a subset of partitions, and they communicate with each other to ensure data replication and consistency. If one broker goes down, the others can take over, ensuring that the system remains operational. Then we have consumers. These are the applications that read messages from Kafka topics. Consumers subscribe to one or more topics and process the messages in real time. They can be part of a consumer group, which allows them to share the workload. This means that if you have multiple consumers in a group, each one will read from different partitions, enabling parallel processing and increasing throughput. A key concept here is consumer groups. When multiple consumers belong to the same group, Kafka ensures that each message is delivered to only one consumer in that group. This is particularly useful for load balancing and scaling out your application. If you need to process more messages, simply add more consumers to the group. Another important component is the zookeeper. While Kafka has been moving towards a more self-managed architecture, Zookeeper still plays a critical role in managing the Kafka cluster. It helps with leader election for partitions, keeps track of broker metadata, and monitors the health of the cluster. It's like the traffic cop, ensuring everything runs smoothly. Lastly, let's touch on Kafka Connect and Sounds Kafka Streams. Kafka Connect is a tool for integrating Kafka with other systems, allowing you to easily move data in and out of Kafka. It simplifies the process of connecting to databases, key value stores, and other data sources. On the other hand, Kafka Streams is a powerful library for building real-time applications that process data stored in Kafka. It allows developers to write applications that can filter, aggregate, and transform data on the fly. In summary, Apache Kafka is a complex yet elegantly designed system composed of producers, topics, brokers, consumers, and additional tools like Zookeeper, Kafka Connect, and Kafka Streams. Each component plays a vital role in ensuring that data flows seamlessly and efficiently, making Kafka a go-to solution for organizations looking to harness the power of real-time data. Whether you're building a data pipeline or a real-time analytics application, understanding these components is key to leveraging Kafka's full potential.